This is a continuation of our quick intro to organic chemistry. We think that Rob Lustig, in his take on fructose, made an important point. If you want to understand metabolism, you do have to understand the basic biochemistry. So in our last presentation, we laid down the general rule. If you want to psych out an organic compound, you look at the structure for two parts, the hydrocarbon backbone and the functional groups. The functional groups are those non-carbon parts, which is where the chemistry is. And we only know one type of compound, but this will illustrate the idea. Suppose we saw this. This is an organic structure showing carbons with a OH group attached. Looking at this, we see a hydroxyl group. So the rule is that anything with a hydroxyl group must be an alcohol. Which alcohol? Well, there are three carbons, and we know that the three-carbon hydrocarbon is called propane, and so this is propanol. So that's pretty easy. And let's summarize what we had before. We have the hydrocarbons, the ethane, propane, and butane. We took off one of the hydrogens and substituted an OH group. We got the corresponding series of alcohols, ethanol, propanol, and butanol. So here's a new functional group. Carbon can actually form two bonds with oxygen. A double bond with oxygen is called a carbonyl group. Do need to remember that name. And if a compound has a carbonyl group at the first carbon, it's called an aldehyde. If the carbonyl is in the middle of the carbon, it's called a ketone. Again, this is greatly simplifying because there are thousands of aldehydes and ketones, but we can generalize around this one functional group. So let's look at some aldehydes. Now this is the two-carbon variant of ethane or ethanol, and there's the carbonyl group. You would call this ethanal, but nobody really calls it that. Small biologically important compounds tend to have common names which you just have to memorize. And so this is called acetaldehyde. This would be called propanal. Again, you take the hydrocarbon name, take off the E, add Al, and that would be the official name. It's frequently called propionaldehyde, and usage is about even between those two. Now, looking at a ketone where the double bond to oxygen is in the middle of the compound, this is a derivative of propane, which would be called propanone. Again, because it's common, it's called, it has a common name, and it's called acetone. And you probably recognize this as the industrial solvent. It's worth pointing out that ketone, the term ketone is used loosely to refer to more complicated compounds that are called ketone bodies, which are the consequence of metabolism under starvation or carbohydrate restriction, and that's a very loose term. But as long as we're talking about metabolism, it's worth pointing out that we already have some clue as to how to analyze what goes on in metabolism, because ethanol, when you metabolize it, is first converted to acetaldehyde. And conversely, a microorganism that carries out fermentation will first make acetaldehyde and then convert that to ethanol. So a little more complicated. What happens if you have a compound with more than one functional group? So if you got more than one functional group, it's all bets are off previously, and is now a combined functional group. And we'll look at the polyhydroxy ketones and aldehydes. That is, compounds that have carbonyl groups and hydroxyl groups. And the simplest of these, look at the ketones first. This is acetone, and this is dihydroxyacetone. Similarly, for the aldehydes, we have propanal and dihydroxypropanal, which again has a specialized name called glyceraldehyde. Now, the important thing about this is that the polyhydroxyketones and aldehydes have a special name, and they are the sugars. They're the simplest kind of carbohydrate. So right off you can see that, contrary to things you hear on the internet, alcohols are not sugars. They're not carbohydrates. Generally, most of the sugars have the suffix -ose. So this is a triose, meaning it has 3 carbons, or a ketose, meaning it has a ketone, or you could describe it as a combination as a ketotriose. So similarly, glyceraldehyde is an aldose or an aldotriose. These are the simplest sugars. They don't have the -ose name, at least in English. In German, glyceraldehyde is called glycerose. So this is our introduction to sugars. We'll do more on that in the future. Looking ahead, the preview that I'm going to show you is suitable for all audiences. When I actually show you the sugar presentation, Lustig doesn't think that it's good for kids to see too much about sugar, so parental guidance is advised. So we're going to see the hexoses. Glucose and fructose are going to be the dietary ones. It's obviously going to be a variation on what we said before. We'll see that they can fold up, and they look like this in a space-filling model. We'll find the carbonyl group, and then I'll show you that they can combine to make disaccharides like sucrose, that's table sugar, or they can polymerize to make polysaccharides, as in starch. And then next time I'll give you an overview of how starch is broken down to its simple components, glucose and or fructose, and we'll look at the general processing of food sugars. So that's it.